Have you ever stared up at the night sky and wondered, are we alone in this vast universe? This is the cosmic question that has intrigued mankind for centuries. The universe as we know it is unimaginably vast. Picture this, it's filled with billions of galaxies. Each of these galaxies houses billions of stars, and around these stars orbit countless planets. Now let that sink in for a moment. The sheer scale of the universe is almost beyond human comprehension. We're but a tiny speck in this grand cosmic tapestry. Yet here on our little blue planet, life has not only emerged, but also thrived. We've built civilizations, explored our world, and even reached out to the stars. Given the vast number of galaxies, stars, and planets out there, what are the chances that all this happened only here? In the enormity of the cosmos, the probability of Earth being the only planet hosting life seems rather slim. Wouldn't you agree? Scientists have been pondering this question for centuries. One of them, Frank Drake, even came up with an equation to estimate the number of civilizations in our galaxy. Delving into the heart of the matter, let's take a look at this Drake equation. Conceived back in the early 60s by astrophysicist Frank Drake, not as a definitive tool, but rather a probabilistic argument to stimulate scientific dialogue. The equation multiplies several variables to calculate the potential number of extraterrestrial civilizations with which humans could communicate in the Milky Way galaxy. Let's break it down. The equation begins with the rate of star formation in our galaxy. It then takes into account the fraction of those stars that have planetary systems. Following this, it considers the number of planets that could potentially support life as we know it, per those solar systems. But the equation doesn't stop there. It further factors in the fraction of planets where life actually evolves, the fraction of life that evolves into a form of intelligent life, and the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. Lastly, it includes the length of time such civilizations release detectable signals. That's a lot of factors, right? But even with the most conservative estimates plugged into this equation, we still end up with a positive number. And a positive number means one thing: the mathematical probability of the existence of extraterrestrial life. While it's true that the values for these variables are largely speculative and the equation cannot give us a definitive number, it does something arguably more important. It shifts our perspective from wondering if there is life beyond Earth to considering how much life could be out there. So, the Drake equation, while speculative, is not about precision. It's about possibility. It's about shifting our perspective and opening our minds to the vast potential that our universe holds. While the Drake equation doesn't provide a definitive answer, it certainly hints at the possibility of life beyond Earth. Life as we know it requires certain elements to exist: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These 6 elements are the building blocks of life, the raw materials from which every living organism is crafted. But here's the intriguing part. These elements aren't exclusive to our little blue planet. No, they are common, abundant even, throughout the cosmos. Carbon, the backbone of all known life, is the 4th most abundant element in the universe. Hydrogen and oxygen, the 2 components of water, are even more plentiful. In fact, scientists have found amino acids, the building blocks of proteins, in meteorites that have fallen to Earth. And complex organic molecules, the kind that could potentially form the basis of life, have been detected in the vast interstellar spaces between stars. It's a fascinating thought, isn't it? The universe seems to be teeming with the essential ingredients for life. In our search for life, we look for planets that might be just right for life as we know it. Imagine a place not too hot, not too cold, not too close to its star, but not too far either. This is what scientists call the habitable zone, or the Goldilocks zone. It's a region around a star where the conditions might be just right, with temperatures that allow for liquid water, the elixir of life, to exist on a planet's surface. But how do we find such planets, you may wonder? Over the past few decades, astronomers have developed sophisticated methods to detect these exoplanets, planets outside our solar system. One such method is the transit method, where we observe a star's light dim slightly when a planet passes in front of it. Another technique is the radial velocity method, where we look for small wobbles in a star's motion caused by the gravitational tug of an orbiting planet. Now let's talk about a fascinating discovery that has stirred the imagination of astronomers and space enthusiasts alike. The TRAPPIST-1 system, located about 40 light-years away in the constellation of Aquarius, this system has 7 Earth-sized planets, with at least 3 of them located in the habitable zone. These planets, named TRAPPIST-1b through to TRAPPIST-1EH, are so close to their parent star and each other that if you were to stand on the surface of one, the other planets would appear prominently in the sky, much larger than the way we see Venus or Mars from Earth. The discovery of the TRAPPIST-1 system is a significant milestone in our quest to find life beyond Earth. It's a clear indication that there are numerous potentially habitable planets in our galaxy waiting to be discovered. So, as we continue our cosmic journey, peering into the vast expanse of the universe, the search for habitable exoplanets becomes an increasingly exciting frontier in astronomy. It's a quest filled with the promise of discovery, the thrill of exploration, and the profound question of our place in the cosmic tapestry. The discovery of potentially habitable exoplanets fuels our hope that we are not alone. We might not need to look as far as exoplanets to find life. Our own solar system holds a few promising locations. Mars, for instance, has been a subject of fascination for years. Evidence of past liquid water and certain chemicals associated with life have been found on the red planet, fueling the hope of discovering microbial life. Then there's Jupiter's moon, Europa. Beneath its icy surface, a vast ocean exists, potentially twice the volume of all Earth's oceans combined. Could this dark, salty water be a cradle for alien microbes? And let's not forget Saturn's moon, Enceladus. This icy body spews water vapor and simple organic molecules into space, the necessary ingredients for life as we know it. Numerous past missions have explored these celestial bodies, and future missions are already in the works. It's an exciting time as we inch closer to possibly finding life beyond Earth. Our very own cosmic backyard may hold the answer to whether we are alone in the universe. For decades, scientists have been actively listening for signals from other civilizations. This quest is not just a figment of science fiction, but a concerted effort led by organizations such as the Search for Extraterrestrial Intelligence, or SETI. SETI's mission is to explore, understand, and explain the origin, nature, and prevalence of life in the universe. They do this by using powerful radio telescopes to scan the skies for signs of intelligent life. But it's not just about sitting and waiting for a phone call from ET SETI's work. Involves careful and methodical study of the cosmos, looking for patterns and anomalies that could suggest the existence of advanced civilizations. They're not just looking for any signal, but for signals that exhibit a clear sign of being artificially produced, a task that requires both sophisticated technology and a deep understanding of the natural phenomena that can mimic such signals. One of the most intriguing moments in SETI's history came in 1977, when a researcher noticed a peculiar signal in the data. Dubbed the WOW signal, it was a strong radio signal detected by the Big Ear radio telescope. The signal bore the expected hallmarks of non-terrestrial and non-solar system origin. It lasted for a full 72 seconds, the full duration Big Ear observed it, but has not been detected again. Despite numerous attempts, the source of the signal has never been identified, leaving the wow signal as one of the most tantalizing mysteries in the search for extraterrestrial intelligence. SETI and similar projects continue to listen, to scan the skies in the hope that one day we might detect a clear sign of intelligent life beyond our own world. We are still waiting for that day, but the search is far from over. Every unexplained signal brings a surge of excitement, a possibility that we might not be alone in the universe. While we have yet to receive a clear message from extraterrestrials, the search continues. After all, the universe is a vast place, and we've barely begun to listen. So, are we alone in the universe? The scientific evidence seems to suggest otherwise. We've journeyed through the Drake equation, a mathematical formula that hints at the probability of intelligent civilizations beyond our own. We've considered the building blocks of life, the fundamental elements necessary for existence, which are scattered throughout the cosmos. We've explored the hunt for habitable exoplanets, worlds beyond our solar system that could host life as we know it. We've contemplated the possibility of microbial life within our own solar neighborhood, from the water-rich moons of Jupiter and Saturn to the subterranean seas of Mars. While we may not have definitive proof yet, the universe is vast and full of possibilities. So next time you look up at the night sky, remember, we are likely not alone.